Hey, um, I want to skip number 6 for right now, since I can use this drawing right here to answer number 7. Number 7, describe the normal sequence of events that occur at the synapse between a neuron and a skeletal muscle. Include the name of the neurotransmitter. Now, a neurotransmitter is a concept that we have not talked about. Every neuron, well, 99% of the neurons that communicate with the target, do not touch the target. Remember, there's a synaptic gap, synaptic space right here in this region between the neuron and the target. Well, there's got to be a way to communicate, to regulate, to activate the target itself, and that is through the release of neurotransmitters. Now, well, I'm going to erase the 1, the 2, and the 3. I'm going to leave my synapse up here for number 7. You don't have to draw it, but I'll use the answer to number 5 to answer number 7, okay? So let me erase the pre-synaptic membrane, post-synaptic membrane, etc., okay? We want to include that in the answer. All right, now, 1 and a 2 and a 3, all right, that's fine. Skeletal muscle, telodendria. Now, the normal sequence of events that occurs in the synapse. So it doesn't matter where the signal originates in the brain, and we will talk about that on the back sheet right here, in a region of the brain called the frontal lobe, where the action potential actually initiates. But let's not worry about where it initiates. Let's travel down the nerve, travel down the neuron to the synapse, and I'll pick up my right hand right here. Let's go ahead and make a fist. Okay? We got flexors and we got extenders. We got flexors and we got extenders, okay? So let's go ahead and flex our fingers right here and make a fist. So the signal is going to go to the flexor muscles of the arm, activate the flexor muscles. The muscles are going to be activated, and we will make a fist. It is that simple. Now let's take a look at the sequence of events that we have right here. The normal sequence of events that occur is action potential arise at the end of the telodendria. That's the first thing. The action potential arises at the end of the telodendria. So here we have an action potential. Here it arises at the end of the telodendria. Number 1, AP. The action potential, the actual signal that the neuron carries, arrives at end of telodendria. Okay? Now, if it wasn't for the release of something between here and here, the signal would be dead. The signal would be dead and nothing would happen, and the muscles wouldn't be activated, and the muscles would be paralyzed. We'll look at a sequence of events, 3 abnormal sequences of events on the back page in just a few seconds right here. So here we have the action potential arriving at the end of the telodendria right here. Now we're going to release a neurotransmitter called acetylcholine. The next step in this sequence of events is step 2 right here. The AP causes the release of acetylcholine. The action potential causes the release. God almighty. Sorry about that. Release. R-E-L-E-A-S-E of acetylcholine, ACH, which is a neurotransmitter. Now I'll go ahead and spell out acetylcholine. Some of you may want to write it out, some of you may not. You can write down acetylcholine, ACH, the neurotransmitter, put neurotransmitter in parentheses, okay? But ACH is equal to acetylcholine. A-C-E-T-Y-L-C-H-O-L-I-N-E. Acetylcholine. It's the only one that's released when we activate our skeletal muscles. It's the only neurotransmitter that we have when we activate our skeletal muscles. So every movement that we have in our body, every movement, is going to involve the action potential arriving at the end of the telodendria, the acetylcholine release, and neurotransmitter, okay, now. So let's go ahead and release my acetylcholine right here. Release my acetylcholine right here. I'll just put me some dots right here for my acetylcholine, right? That's my acetylcholine, that's my acetylcholine, that's my acetylcholine. Now, so the gap is very small, but there is a gap there. The acetylcholine diffuses across the gap. It's simple, a matter from high concentration to low concentration. Acetylcholine, our neurotransmitter, diffuses across the gap. That's my next step right here. ACH diffuses, D-I-F-F-U-S-E-S, across the gap. All right. 4. Now, I've got to have a place for this acetylcholine to attach. There's a receptor site on this postsynaptic membrane for the acetylcholine to attach. So my step 4 is acetylcholine attaches to receptor site on postsynaptic membrane. Now I may put that over here, but that's what it's going to be, acetylcholine. I'll try to write it right there. I'm really suck. Got to get this lower here. Acetylcholine attaches to receptor site on postsynaptic membrane. I'll try to write that right here. ACH attaches to receptor site. I'm sorry, that ain't gonna work right there. Let me put it over here. I hope I can get this in right here. Number 4 right here. ACH attaches to receptor RECEPTOR site on postsynaptic membrane. Now, I hope you can see this over here. Acetylcholine attaches to a receptor site on the postsynaptic membrane. Now, the last step is fairly simple. Target activated, skeletal muscle activated, skeletal muscle contracts. So you step number 5 right here, step number 5, which I ain't going to attempt to write over there. I'll put it over here, step number 5 right here. Skeletal muscle contracts. The skeletal muscle contracts. Now every time that we do this right here, the muscle contracts. There is something else that's involved right here. I said that step 5 was the last step. I lied to you. Step 6 is the last step. I got to break down the neurotransmitter for the skeletal muscle to relax. Now this is what's going to break it down, and this is very important. Now my step 6 right here. My step 6 right here is ACH is broken down by an enzyme called acetylcholinesterase. We will abbreviate it. Calm down, you can get this right here. ACH broken down by ACHE. ACH is acetylcholinesterase. Muscle relaxes. This is the last step. Muscle relaxes. But that's a sequence of events that occurs in the action potential. Every time a skeletal muscle activates. Now, I can't snap my fingers very fast, but I blink my eyes fairly fast. You can too. This is the sequence of events that occurs every time you blink your eyes. Flutter your eyes. Hi. Flutter your eyes right there. And that's how the sequence of events that occur, that's how fast that they can occur. Okay, now I want to go back to the one above, number 6. All right, number 6. And I probably will quit with this for today and I'll finish it tomorrow. Question number 6. All right. I got to go back to my neuron. Got to go back to my neuron right here, okay? Put a piece of chalk here. Number 6 reads, what 3 areas of the neuron will be affected by drugs? List 2 opioids, explain how they work, all right? This will be the last one that I'll do for today, and I'll pick back up on this tomorrow. I want to show you my neuron. You don't have to draw this, but it's easier for me to explain it to answer your question. I'll give the answer in just a few seconds. For number 6. Three areas. You simply list them right here. I've got to initiate the action potential. I've got to propagate it. I've got to transmit the action potential. Those are going to be my 3 areas. Initiation. And I don't really keep you drawing circuit right here. You can if you want to. If you let you, then do it. Initiation of action potential. Step 1. INITIATION of action potential. Step 2. Propagation, sending it down the axon. Propagation is this next step. Next area. P-R-O-P-A-G-A-T-I-O-N. And the third area right here is a transmission, conveying it to the synapse, activating and regulating the target right there area. Transmission. Initiation, propagation, transmission. Now let's two opioids. Went online a while ago. Excuse me. Looked up Wikipedia and looked up opioids. O-P-I-O-I-D-S. I always spell the damn thing wrong. But anyway, looked up opioids right there. And it is unreal, the names of synthetic opioids. Morphine, codeine, oxys. I don't really care which ones that you list. Morphine is one. Codeine is one. Oxys is another one. Okay. Hydrocodone is another. So there's I don't know, 25 or 30 different opioids that we have right here. But you can just list me to morphine and opium are two opioids that we have right here. Now, these are given for pain. Excuse me. Excuse me. These are given for pain sensation. Now, one of the areas that the pain is going to be blocked is in the brain, in the upper region of the brain stem called the thalamus. So in the thalamus, this is what I'll be looking for your answer. It blocks the release of the neurotransmitter, of the pain neurotransmitter. All right, so our answers are, besides morphine and codeine, morphine and opium, whatever that you want right there, it blocks the release of the neurotransmitter in the thalamus. That's what I'll be looking for. Blocks the release of the neurotransmitter. And I might as well go ahead and give you the name of the neurotransmitter. It's very complicated. It's called substance P. All right, so let's think about this just for a few seconds. Substance P